Last time we had gotten to the point where we found the cosine of 15 pi over 8 was the square root of 2 plus the square root of 2 over 2. And we had hit upon the fact that, and we were actually asked to find the secant of 15 pi over 8. So we're going to pick up there. Now looking for what the secant would be. So clearly, secant and cosine are reciprocals. So the first thing that we're going to do is we're going to flip this fraction upside down. So we now have 2 over the square root of 2 plus the square root of 2. And we're going to treat this just like we have before. We're not allowed to keep a radical in the denominator. So the first thing we have to do is we have to actually multiply the denominator by the radical that it itself is equal to. So we have square root of 2 plus the square root of 2. So I end up in my numerator with 2 square roots of 2 plus the square root of 2. And in the denominator, I end up with 2 plus the square root of 2. Now, again, this is a little unusual, right? Because at this point, we usually end up with a denominator that's in rational form, and we don't here. But we have seen what to do when we have a denominator that looks like this. We multiply by what we call the conjugate, and that's 2 minus the square root of 2 now. So the denominator will in fact become rational. It will become 4 minus 2. The numerator will have a 2 in it. It will have a 2 minus the square root of 2 in it. And it will have a square root of 2 plus the square root of 2. So this denominator obviously is still at play here, and it's equal to 2. So it will actually cancel with the numerator 2. And all I end up with left is 2 minus the square root of 2. And all of that is in parentheses times the square root of 2 plus the square root of 2. And that will be our final answer for the secant value. All right, so the other thing in this section, of course, is verifying identities or establishing identities, and we're going to take a look at 3 examples of that. The first one we're going to look at is a double angle for secant. So the first thing, taking a look over here, I'm supposed to be finding this is equal to a secant double angle, and I've got secant squared plus secant to the 4th over 2 plus secant squared minus secant to the 4th, and I don't know about you, but it just screams factor me on the right-hand side, so that's what I'm going to do. The first one, I can pull out a secant squared of x, and I'm left with 1 plus secant squared of x. And the 1 plus secant squared, I would actually have a chance at the denominator being able to cancel out with. So I'm going to try and see if I can get a 1 plus secant squared of x in that denominator when I'm factoring. Of course, I need another 2 here in order to get the 2 times 1 is 2 at the beginning, right over here. And then I need a minus sign because I need to get a subtraction sign on secant squared. Or sorry, secant to the 4th at the end, so it's a subtraction sign. And then the last thing that I need is this will actually try that for secant squared because I need secant to the 4th, and so I don't need any numbers in front of that, or I won't have secant to the 4th. So we can check out, of course, if I multiply the first terms together at 2. If I multiply the outside terms, I've got 2 secant squared, and the inside it's negative secant squared, so that would be a positive secant squared, which is what I want. And the last 2 terms would be minus secant squared, and so everything in fact does factor, allowing me to have a 1 plus secant to cancel in the numerator. Now from here, again, I don't have a double angle formula for secant to theta, or secant of 2x in this case, but I can write this in terms of cosines, like on the last problem. So this is going to be 1 over cosine squared of x over 2 minus 1 over cosine squared of x. And as is my custom, of course, I want to get rid of those fractions. So I'm going to multiply by cosine squared x on top and on bottom. And so on top, I actually get the number 1. And then on bottom, I get 2 cosine of cosine squared of x. And then I get minus 1. And if you look very quickly back at those identities that we did at the beginning, I'll flip to them. That is one of the forms of double angle identities. It's the second form on this slide. 2 cosine squared theta minus 1. So in fact, I have on bottom here cosine of double angle 2x, and 1 over cosine of x would in fact be the secant of 2x. So that one's finished. A couple more. Let's look at number 4. Number 4, I have sine of 2 alpha cosine of 2 alpha equals sine of 2 alpha minus 4 sine cubed of alpha cosine of alpha. And there are a lot of different things we could be doing with this. I'm going to work on the right-hand side. You may be inclined to work on a different part of this, and that would be fine. But let me start on the right-hand side and show you what I see when I look at this problem. So I see that on the right-hand side, my angles don't match, which is rather unhelpful. I need to be able to combine terms, and if the angles don't match, I can't do that. So I've got sine of 2 alpha here, so I'm going to change that using the double angle identity into 2 sine of alpha cosine of alpha. And still I have minus 4 sine cubed of alpha cosine of alpha. And the nice thing in having done that is that I have some terms anyway that match. I have a 2 in every term. I actually have a sine in both terms as well. And I have a cosine in both terms. So I actually factored out everything that I just changed that very first term sine 2 alpha into. So I have 1 minus, and I have a 2 here, and then sine cubed is sine cubed cosine rather, pulling out a sine and a cosine is going to give me sine squared. And then looking back at those double angles like we did just a moment ago, I have 2 sine alpha cosine alpha, well that's sine 2 alpha. And I have 1 minus 2 sine squared alpha, which is cosine 2 alpha. So this piece right here is the sine 2 alpha that I took out just a moment ago. And this piece right here is cosine of 2 alpha. And that's exactly where I wanted to end up. That one's actually really fairly clean after we made the one change in identity form. All right, the last one we're going to look at is cosine theta is equal to 1 minus tangent squared of theta over 2 over 1 plus tangent squared of theta over 2. So this is our first one that we've seen, a theta over 2, that is a half angle in this. And if you take a look at the tangent half angle formulas, oops, too far. You actually see that it has 3 forms. And I'm going to be inclined on this particular problem to change it into the one that's got the radical in it. And the reason is because that radical is going to be squared in the problem, because both of those tangents in my problem, those half angle tangents, are squared. So the square roots are going to go away very quickly. And so that's going to be actually a helpful formula in this particular case. All right, so we have 1 minus, and then I have the square root. Technically I have plus or minus of it, but again it's going to cancel out with the squared at the end, so I don't necessarily have to write that down. But you could if you would like to see that, of course. So 1 minus cosine alpha over 1 plus cosine alpha. And that's squared. Over 1 plus, and the same thing. So the square root of 1 minus cosine alpha over 1 plus cosine alpha. And that's squared. So of course I end up with 1 minus and that same thing, but not square rooted anymore. So 1 minus cosine alpha over 1 plus cosine alpha over 1 plus, 1 minus cosine alpha over 1 plus cosine alpha. And of course those little denominators, they match, and again, as is my custom, I want to get rid of them, so I'm going to multiply by 1 plus cosine alpha over 1 plus cosine alpha. And this gets distributed to each of these 2 terms in the numerator and the denominator. Of course, when it gets multiplied by 1, I just get 1 plus cosine of alpha. Oh, and I'm using alphas everywhere. My original problem had thetas in them, so please forgive me for that. I'll see if I can try and fix them. Although it probably would have been easier, I guess, at this point to have actually just changed the problem, but that's okay. We'll get it fixed. So this is theta because you should keep the value the same as you're working. Okay, all fixed. And then we have the negative, and then I've got the 1 minus cosine alpha, or cosine theta over 1 plus cosine theta times 1 plus cosine theta. And so the denominator is going to cancel with the term I'm multiplying by, so I'm actually going to get 1 minus cosine of theta here at the end. And then on the denominator, I've got 1 plus cosine theta. And then I have a plus sign, and then I'm going to have that same numerator for the exact same reason, 1 minus cosine of theta. All right, this is equal to cosine of theta, so what I want to do next is I'm going to move this to the next slide and simplify those denominator and numerator just a little bit. And I think things will fall out really nice, and we'll be able to finish up pretty quickly after that. So here's my formula, and we'll distribute those negatives. So I have 1 plus cosine alpha, or cosine theta minus 1 plus cosine theta over 1 plus cosine of theta plus 1 minus cosine of theta. So in the numerator, of course, I've got a positive 1 and a negative 1, so those add to 0. And then I've got 2 cosine thetas, so this is actually 2 cosine theta on top. And then in the denominator, I have a cosine theta and I have a negative cosine theta, so those add to 0, but I have a 1 and a 1, and those add to 2. And then, of course, clearly my 2's can cancel, so I end up with cosine of theta, which is what I was looking for.